Okay, so what we are going to do now is we are going to look at the titration of a weak acid with a strong base. And that is the problem that's given on the board. So we have our weak base, which is 2-nathoic acid, with our strong base, which is sodium hydroxide. So we want to create a titration curve finding the pH at the different volumes. And then what we'll be able to do is we can eventually, if we did it plotted enough points, we can create our titration curve. And we already know, based off of what the approximate shape should be from previous lectures, that it should look something like this. Volume of my titrant, which is my sodium hydroxide, and it's going to be in milliliters. Then, on my y-axis, I'm going to have my pH. And remember, it's a weak acid, so it's going to start with a low pH and then go to a higher pH. So we should expect something like this. So here's my weak acid, my titration curve, and then my equivalence point is shown here on the plot. And we'll start with a low pH, go to our equivalence point, and go after. So the very first thing that we are going to have to do, first two things whenever you see that it's a weak acid problem, is that you want to find what this volume is at your equivalence point. V sub E, very first thing. And then the second thing that you're going to want to do is find what the pKa is. And from this, for this particular problem, you're going to look at it in your book. So in your book, there is in your appendix, on page 30 in your appendix, there's 2-nathoic acid, and the pKa is 4.16. So for this one, the pKa equals, and then the Ka equals 6.9 times 10 to the minus 5. Okay, so find the pKa, Ka, there they are. You find them from a table. Now let's find the volume at the equivalence point. So the volume at the equivalence point, in this case, is the number, it's the volume that would be required to fully react the acid with the base that we add. So to do that, we are going to use the volume in liters of our acid that we added. So this is 50.0 milliliters, and I converted it to liters. Then I'm going to use the concentration of it, which is 0.0500 moles per 1 liter, and this is for my HA. This is my nathoic acid. Okay, and then we know that there's 1 mole HA to 1 mole of NaOH. And then we know that the concentration is 0.100. And this equals 25 milliliters, or 0.0250 liters. And this is for my sodium hydroxide. And moles of HA cancel out. It's the same as 25 milliliters. Okay, so we know that one of the volumes that we're interested in is 25.0 milliliters, and that's the volume at our equivalence point. So very first thing we need to do is find that initial pH. And that initial pH is the very first step we want to do. So initial pH, and that's when the volume of your base, V sub B, equals 0. Okay, so you have your acid, you add it in water, and because it is a weak acid, it partially dissociates, giving you this equation here. And then what you need to do is, because it partially dissociates, think Ka. So Ka is going to equal x squared over concentration, which your initial concentration was 0.0500 minus x. If you write out what the Ka is from your equation, you would also know that is H plus A minus over HA. So this part is a review, but you would set up your Ka, x squared, and then you would solve for x. And we already know that Ka is 6.9 times 10 to the minus fifth equals x squared over 0.0500 minus x. So if you do the math out, you'll notice that this, if you want to negate the minus x in the denominator, you must, this concentration must be over 1,000 times greater than your Ka. This is in fact not the case, so to solve for x, you will need to use the quadratic equation. And you'll solve, and you should find that your x is equal to 1.82 times 10 to the minus third molar. Then what you'll do, your x is the same thing as your H plus concentration, then you're going to find the pH from that. And pH is equal to negative log of 1.82 times 10 to the minus third molar, which equals 2.740. So this is the first point on your curve, 2.740. Okay, so that's the very first thing. Then we have the next video. We'll talk about how we get to the 8.0 milliliters, and we'll also cover how we got the pH at 25.0 milliliters. So that'll be the next video.